Symmetry operations in crystals. Symmetry operation is that operation which when applied to a crystal structure leaves the crystal structure invariant, that is the structure remains same. We have four types of symmetry operations. One is translational, rotation, reflection and inversion. Translation symmetry operation. It is the operation which when applied to a lattice point gives you a new lattice point which has identical surroundings like first lattice point. For example, let us consider lattice point P at a distance of r vector from origin O, and we are applying translation operation to this lattice point. So it gives a new lattice point Q at a distance of r dash vector, and this new lattice point has identical surroundings like this first lattice point. So we have r dash vector is equal to r vector plus t vector. It is when we apply translation operation to this P lattice point, we get a new lattice point Q. And translation vector t, it is given by n a vector plus n b vector. A and b vector are translation vectors. According to our example, the lattice point P, it moves to lattice point Q. So we have 1a vector and here minus 1b vector. So we have equation t vector is equal to minus a vector plus b vector. Rotation symmetry. A crystal is said to possess rotation symmetry if crystal remains invariant after rotation angle theta. For example, let us consider a square crystal ACDB. It has an angle of 90 degree and now we are rotating it along the clockwise direction. So the crystal looks like this now. It is invariant. But the point A, it is moved here, A, C, D, B. So now again we are going to rotate it clockwise at a 90 degree. So we have B, A, C and D. And then we are rotating again at an angle of 90 degree. Then we will be having D, B, A, C. And then again we are rotating to an angle of theta 90 degree. We have A, C, D, B. So after four-fold rotations, we have the crystal which is similar to of the original A, C, D, B. Here also A, C, D, B. So this square crystal, it has a four-fold rotation. That means n is equal to 4. So n theta is equal to 360 degree and theta is equal to 360 by n, where n is equal to 1, 2, 3, 4. N is not equal to 5-fold and n is not equal to 7-fold rotation. So in our example, we have n theta as 90 degree which is equal to 360 degree. So n is equal to 360 by 90 which is equal to 4. Reflection symmetry. A crystal is said to possess reflection symmetry if there exists a line or a plane which divides the crystal into two identical halves which are mirror images of each other. Inversion symmetry. A crystal is said to possess inversion symmetry if for every lattice point at a position R, there exists a lattice point at a position minus R. It is applicable to 3D lattices only and it is a point operation.